Good morning, everyone. I am Mr. Mohapi TV. I am from Putswa district. Today we will be having a presentation or a lesson presentation on optical phenomena, focusing on photoelectric effect. That is what we will be discussing today. So, let us start. The lesson outcomes are as follows. What we need to do here, what we need to know from this topic, we need to know the following definitions. We have photoelectric effect. We must be able to explain what photoelectric effect is. We must also be able to explain what function is. We must also be able to define threshold or cutoff frequency or wavelength. Then we will do calculations based on photoelectric effect formula. Then we will then explain the effect of intensity and frequency on photoelectric effect. And lastly, we will end with the activities on this topic. Without wasting time, I would like to start. So the topic photoelectric effect. Photoelectric effect. This topic basically explains to us how a light or solar can be used to produce electricity. That is basically what this topic involves. So we are going to explain how light or how solar can be used to produce electricity. Let us start with the definition of photoelectric effect. Photoelectric effect is defined as follows. It is the process, this is the process whereby electrons are ejected or released from the surface of the metal when light of suitable frequency is shown onto it. So photoelectric effect is defined as the process whereby electrons are ejected or released from the surface of the metal when light of suitable frequency is shown onto it, is shown onto the metal. It is very, very important that we understand what do we mean by suitable frequency. Suitable frequency, we emphasize it, or we should emphasize it, because it then tells us that it is not every light or it is not every light that will be able to release or eject electrons from the surface of the metal. It means that some light can be able to eject electrons from the metal surface, and there are those that will not be able to eject electrons from the metal surface. How do you then determine the suitable frequency? A suitable frequency will be the frequency of the light that is greater than what we refer to as the threshold frequency. If the frequency of the light is greater than the threshold frequency, then electrons will be able to will be ejected from the surface of the metal. But if the frequency of the light is less than the threshold frequency, then it means electrons will not be ejected from the surface of the metal. So it is important to understand this thing of suitable frequency. Suitable frequency means that the frequency of light is greater than the threshold frequency. We will explain what threshold frequency is. And if the frequency of the light is greater than the threshold frequency, it then means that electrons it then means that electrons will be ejected. But if the frequency of the light that is shown onto the metal is less than the threshold frequency or the cutoff frequency, then this then implies that electrons will not be ejected will not be ejected from the surface of the metal. That is what we mean by suitable frequency. So even when you do your definition of this photoelectric effect, please note that part of suitable frequency and know the meaning of that. Now let us get to the threshold frequency and explain what do we mean by the threshold frequency. Threshold frequency, or the cutoff frequency, this here, it is the property of the metal. It is important that we understand that threshold frequency or cutoff frequency is the property. It is the property of the metal, meaning this depends on the what? On the metal. So your metal, or each metal, has got its own cutoff frequency, which is the minimum frequency. This is the minimum frequency needed to eject electrons, minimum frequency needed to eject electrons from the surface of the metal. From the surface of the metal. So this threshold frequency, like I said, that it is the property of the metal. The only way we can change the threshold frequency or the cutoff frequency is by changing the metal. If you change the metal, then the threshold frequency will also change. For instance, if you have a zinc metal and then you are moving from zinc metal to maybe a copper metal, then it means you will then have a different threshold frequency, which is the minimum frequency needed to eject electrons from the surface of the metal. So, like I said previously, if the frequency of the light that is shown onto the metal, if that frequency is greater than this minimum frequency that is needed to eject electrons from the metal surface, if it is greater, the frequency of the light that is shown onto the metal, if it is greater than the threshold frequency, then it means electrons in that case will then be ejected. Here electrons are ejected because the frequency of the light will be greater than the threshold frequency being what? Being the minimum required frequency to eject electrons from the surface of the metal. That is what I have explained earlier. But if it happens that the frequency of the light is less than the threshold frequency, then, like I said earlier, electrons will not be ejected from the surface of the metal. That is very, very important that we understand. It goes back to the suitability of the frequency. So we need to understand that the frequency of the light that we are going to shine on the metal must be greater than the threshold frequency for us to be able to eject or release electrons from the surface of the metal. Because if the frequency of the light is less than the threshold frequency, electrons will not be ejected. But we have some instances whereby the threshold frequency and the frequency of the light are equal. In such cases, then it means electrons will just be released, but they will just have vibration. They will not go anywhere. We'll explain that when we move forward to photoelectric effect formula. But we needed to understand how electrons are ejected from the surface of the metal. That is very, very important. Now, moving forward, what then happens is, I'm going to draw a sketch here of a metal. Let us say we're having a metal here, and then on this metal we are having electrons they're situated on this metal. And when light is shown onto the metal, when light, let's say it is the sun, for instance, when it is shown onto the metal, what will happen is the photons that will be coming from the light or from the sun will then go and hit the metal, and as they hit the metal or the electrons, because as they move, they come as packets of energy. And the packet of energy is given by E being equals to Planck's constant multiplied by frequency. So when light is shown onto the metal, it will move, the photons move as packets of what? Of energy. The packet of energy that is given by E being equals to the Planck's constant multiplied by the frequency. So when these packets of energy reach the metal, the energy will then be transferred to the electrons that are on the metal. And once they are transferred onto the metal, or onto the electrons, then electrons will then use the energy that they have gained from the photons, want to do what? To be released from the metal, and with what is left, then they will then be use that energy to move away. Hence, we'll be talking about the kinetic energy. So the packet of energy that will reach the metal, the electron, it is given by E, which is the energy that is given by HF. And from this formula, we can see that this energy depends on the frequency. Let us say then we have our energy as 25 kilojoules. I'm just making an example here. If the energy that has been transferred onto the electron is 25 kilojoules, what will the electron do? The electron will use some of this energy to do what? To be released from the surface of the metal. And with the energy that will be left, then the electron will then use that energy to move away from the metal. And like we talked about the minimum frequency, then when it comes to the minimum energy that is needed to overcome or to release electrons from the surface of the metal, we can then talk about the work function. Work function is given by H multiplied by threshold frequency. This work function is defined as the minimum energy, needed to eject electrons from the surface of the metal. Work function together with the threshold frequency. These two variables are the properties of the metal, like I said, with the threshold frequency. And you can see that the work function depends on the threshold frequency and vice versa. So if you want to change the work function, like I said with the threshold frequency, you will then have to change the metal. When you move from one metal to another metal, then it means the work function and the threshold frequency will do what? Will change. Work function is the minimum energy needed to eject electrons from the surface of the metal. So the energy of the photon, or the packet of energy, the quantum from the sun, has been hits or is shown onto the metal, and the photons are then transferred to the electrons, not the photons. The energy of the photon is then transferred to the electron, and the electron will use that energy that it had gained from the what? From the source of light, which sometimes can be what? Can be your sun. It will use, the electron will use that energy, one, to be released from the surface. And what will be left from that energy? It is the energy that the electron will use to move away from the what? From the metal surface. Now, because this energy of the photon, once it hits an electron, all of the energy of the photon will be then transferred into the what? Into the electron. Meaning an electron will now have what we said here. We made an example that let's say energy of the photon is 25 kilojoules as an example. Let us say the work function here, it is what? It is 20 kilojoules. Let us say the work function is 20 kilojoules. Meaning, if 25 kilojoules of energy has been transferred to the electron, all of the energy from the photon is transferred into to the what? To the electron. So we will then have energy of the photon being 25 kilojoules, and then we have work function being equal to 20 kilojoules. What then happens is the electron will then use, out of 25, will then use 20 kilojoules of energy, because here we have in 25, that is with the electron, and then the electron will use 20 of that 25 just to be released from the surface of the metal. And then the electron will then be left with what? With 5 kilojoules. This 5 kilojoules that now our electron is left with, it is the energy that the electron will use to move away from the what? From the surface of the metal. But it is important that we understand that when an electron has now gained the energy from the photon, then we no longer refer to it as an electron, but we refer to it as a photoelectron, because it has gained electron energy from what? From the light. So now this is then referred to as a photoelectron. So the 5 kilojoules that is left will then be used to move. And we know the energy due to motion of anything is given by what? Is given by kinetic energy. That is where this formula of photoelectric effect comes from. An electron has gained energy from the photon. What will the electron do with that energy? One, the electron will use some of that energy just to be released from the surface of the metal, and what is left will then be used by the electron to move away from the what? From the surface of the metal. And because here we are talking about energy due to motion, we refer to that as what? As kinetic energy. But it is important, again, we understand that here we are talking Kmax. Kmax, because all of that energy that is left, all of it to the maximum, will be used to move away from the surface of the metal. That is very, very important that we understand. So the formula here is E, which is energy of the photon, is equal to work function plus kinetic energy maximum. We say maximum because whatever that is left will then be used, all of it, to move away from the surface of the metal. I hope you are still with me there. And this then implies that for us to have our electrons to move faster, we'll then have to increase the energy of the photon. How do you increase? In fact, how do you change the energy of the photon? Energy of the photon, like I showed you earlier, is given by Planck's constant. This is Planck's constant. is given by Planck's constant multiplied by what? By frequency. Frequency is the property of light. This one is the property of light. This frequency depends on the light that has been used. It can be a color or whatever. So if you change the light, meaning you will change the frequency. So if you want to release electron and for them to move at a higher speed, it means you will then have to move from a light of a lower frequency to a light of a higher frequency. When you do that, then it means that the kinetic energy of the metal, of the photoelectrons will increase. Let us make an example. Let's say we are moving from 25 kilojoules and then we are moving to, let's say we are moving from 25 kilojoules plus K max. Plus K max. Let us say we are moving from 25 kilojoules to a higher frequency. Let's say now we have energy of the photon being fed. A work function will not change because we have not changed the metal surface. Remember I said that the work function is the property of the metal surface. So the only time the work function will change, it is when we change the type of the metal that we are using. Maybe when you move from copper to zinc or from whatever, platinum to silver, whatever metal you are moving to. So this one will be constant. This one will be constant because we are still using the same metal. Now it is 30, but because we are still using the same metal, here we'll still have 20 kilojoules. And then in this case, now the kinetic energy will be how much? Will be 10 kilojoules. So it is important that we understand this thing, that for us to increase this, the kinetic energy of the metal, we need to use light of a higher frequency. Because once you use light of a higher frequency, then it means energy of the photon will do what? Will increase. But the work function will remain the same since we are using the same metal. And then at the end, the kinetic energy of the photoelectrons will do what? Will increase. That is very, very important that we understand. Okay. Now, when you have the kinetic energy there, we'll have E is equals to work function plus kinetic energy maximum. But we know that kinetic energy is given by half m. We say, because we are dealing with photoelectrons here, we say m of an electron, mass of an electron multiplied by speed squared. But because we are talking of maximum kinetic energy, then it means even the speed will be the maximum what? Maximum speed of the electron. This also can be expressed in terms of what? In terms of the frequency or threshold frequency. We can then have F naught. That is the threshold frequency, and our energy can also be expressed in a form of HF, like I've shown earlier, that this energy of the photon is given by the product of Planck's constant and the frequency of the light. So sometimes we might need to express this thing with the what? With the wavelengths. If we do that, we know we have a formula where it says speed of light is given by frequency multiplied by what? Multiplied by wavelength. This speed of light, because we are dealing with light here, the speed of light is 3,0 times 10 to the power 8 meters per second. And then here we are having frequency and the wavelength. So if we make frequency, wavelength subject of the formula, we are then going to have a formula which is C over what? Over the frequency. So we are going to now express this thing in terms of the wavelength. So if we want to do that, if we want to do that, or rather, we make frequency subject to the formula. We say frequency is equals to C divided by wavelength. So where we see the frequency, we can then put on speed of light over what? Over wavelength. Then we will have a formula such as this one, which is h and then divided by wavelength, because where we had frequency, we have now replaced it with what? With the speed of light over the wavelength. And then moving forward on this side, the threshold frequency also goes with what? With the threshold wavelength. Threshold frequency goes with the threshold wavelength. Threshold wavelength, like we have been doing with the threshold frequency and the work function, it is the minimum wavelength that is needed for an electron to be ejected from the surface of the metal. So this one will then be C over lambda naught. And then on this side, we still have what? Half mv squared max. I am expressing this formula of photoelectric effect in different ways, because sometimes we will not be given the work function or the energy of the photon. Sometimes we'll be given the frequency, and then we'll be given the threshold frequency. So if that is the case, then it means that we need to move from this formula to this formula so that we can be able to substitute our frequencies, which is the frequency of the light and the frequency, the threshold frequency. And sometimes, again, depending on the information that is given, sometimes we may be given the wavelength of the light. If we are given the wavelength of the light, then it means that the energy of light will then have to be expressed in what? With the wavelength. And when we express it with the wavelength, we will then have hc over what? Over wavelength. And then here, even when you are given the threshold wavelength, then it means that you will have to express the work function in terms of the threshold wavelength. When you do that, you will have hc over lambda naught plus half mv squared. I am expressing this formula in different ways because we do not know what the examiner will assess us. Maybe they might give us the energy of the photon and the work function. Then it will be easy for us to use this formula to do our calculation depending on what has been asked from us. Or the examiner might give us the frequencies. If we are given the frequencies, then we can use this expression as the one that we will use to do whatever calculation that will be required from us. If we are given the wavelength, then it means we'll then have to express that very same formula in terms of the wavelength. And when we express it in terms of the wavelength, we'll then have C over lambda. And then here we'll have C over lambda naught. Lambda naught, that is your cutoff or threshold what? Wavelength. Then then we add it to what? To the maximum kinetic energy. Remember, this formula only works if the frequency of light that has been shown onto the metal is greater than the threshold frequency. You are not going to have this formula. You are not going to have this formula if the frequency of the light is less than the threshold frequency. For us to have maximum kinetic energy, it means that electrons must have energy that is greater than what? Must have gained energy that is greater than the work function from the what? From the light. That is very, very important. And it is important that learners understand how this thing of photoelectric effect work. Fine. So we have now explained where this photoelectric effect formula comes from. And we are going to use this photoelectric formula to solve problems at the later stage. But it was important that I explain where this comes from. Now we are moving on to the factors that can affect the photoelectric effect of ours. Photoelectric effect, remember the aim of photoelectric effect is to produce electricity. Here we are producing current, we are producing electricity. So the amount of the current that we are producing can depend on the intensity of light intensity of light, and again, they can depend on what? On the frequency. On the frequency of what? Of light. So these two variables can affect the current that we are going to produce. Frequency of light. We'll then explain how intensity of light affect the current that we are going to produce. Intensity of light. Intensity of light. With intensity, when we increase the intensity, then it means you will have more photons hitting the metal surface. But it is important to understand that the intensity of light that we have to increase, it must be the light that is able to release electrons from the surface of the metal. Even if you can increase the intensity of the light that does not have a frequency that is greater than the threshold frequency, increasing the intensity will not have any effect. So intensity that we change, it is the intensity of the light that has the frequency that is greater than the what? The threshold frequency. Increasing the intensity of the light that has the frequency that is less than the threshold frequency will not help, will not do anything on the photoelectric effect or the current that we want to produce. So intensity that we increase, for us to increase the amount of the current that we want to produce, it must be the intensity of the light that is that has the frequency that is greater than the what? The threshold frequency. So what then happens when we increase the intensity of light? When you increase the intensity of light, then it means that we are now going to have more photons hitting the surface of the metal per second. We'll have increase in intensity, implies that we now have more photons. We'll now have more photons hitting the metal surface per unit time. So increasing the brightness, increasing the intensity of the metal, it means now you'll have more photons hitting the metal surface per unit time. I'll just draw here. Let's say you are having electrons here on this surface. Let's say this is situation 1. And then here we also have another metal. Let's say in both metals you are having what? You are having 4 electrons on the metal surface, as an example. So for a dimmer one, dimmer light, meaning light of low intensity, then it means here, because we are having a low intensity of light, then the photons that will be hitting the metal, maybe we'll have 2 photons hitting the metal, and then we'll have 2 electrons that are released from the surface of the metal. But if now you have a brighter light or light of higher intensity hitting the metal, you will now have more photons. You'll now have more photons hitting the what? Hitting the metal surface. So here in this case, we are now having 4 photons hitting the surface of the metal, meaning you will then, in this case, release more electrons. Here, because we were dealing with a dimmer situation or lower intensity of light, you now have fewer photons hitting the metal surface. And having fewer metals hitting the surface of the metal implies that you will then release fewer electrons, which will now be what? Your photoelectrons. So increasing the intensity of the light increases the number of what? Of the photoelectrons released per unit time. So the second point on this thing, when you have more photons When we have more photons hitting the metal, then it means you will then have more photoelectrons released per unit time. That is what it implies, that when you increase the intensity of light, then it means that you will have more photons hitting the metal surface per unit time. And when you have more photons, we are moving from situation A to situation B. You had fewer photons hitting the metal here, and then now you are having more photons hitting the metal here. Because you have more less photons hitting the metal here, then it means you are going to release fewer electrons, which will now be photoelectrons. And then here, because you have more photons hitting the metal, then it implies that we will then have more electrons or photoelectrons released per unit what? Per unit time. That is how intensity affects the production of what? The production of electricity or current in what? In photoelectric effect. So this then implies that according to the formula of the current, we know current is given by charge over what? Over time. So if photoelectrons, these are the charges, if this increases, then it means your current will also do what? Will also increase. If you increase the amount of charge that is being released, then it means according to this formula, your current will also do what? Will also increase. That is how intensity affects the current that is being produced in photoelectric effect. We'll now move on to frequency of light and check how frequency of light affect the current that is being produced through the process of what? The process that is known as the photoelectric effect. When we move to frequency, remember frequency is the property of light. This here is the property of light. The only way we can change the frequency of light, or the only way we can change frequency, is by changing the light. Meaning if you are moving from blue light to green light, then frequency of light will do what? Will change. And if this frequency is increased, meaning you have now moved from light of a lower frequency to a light of a higher frequency, maybe you are moving from red light to blue light, then frequency will increase. Let's talk about increase in frequency of light. If we increase the frequency of light by moving from one type of a light to another type of a light, this is what will happen. We know that if the frequency of light increases, if frequency of light increases, then energy of the photon, energy of the photon will also, energy of the photon will also increase according to this formula of the photon, energy of the photon, HF. Because Planck's constant is a constant, then it means energy of the photon will depend on the what? On the frequency. So if you are using light of a higher frequency, then it means energy of the photon will do what? Will increase. And once that happens, then it implies, I've touched on this briefly earlier, but then now we are going to get into more explanation on that. So energy of the photon has increased. What are the implications of this? We have seen that according to this formula, E is equals to work function plus kinetic energy max. So if this increases and then this is constant, work function is constant, then it implies that the kinetic energy or maximum kinetic energy of the photons or photoelectrons will do what? Will increase. When you increase energy of the photon, how do you increase energy of the photon? You increase energy of the photon by using light of a higher frequency. And once that is the case, for constant work function, then it means kinetic energy maximum will do what? Will increase. So here we'll say, once this has happened, we'll have our kinetic energy max increases according to this formula. And then what then happens when the kinetic energy of the photoelectrons increase? Because kinetic energy max is given by half m of an electron multiplied by V max squared, and the mass of the electron is constant. Mass of an electron is constant. So when you have increased the kinetic energy of the photoelectrons, then it means the speed of those photoelectrons will do what? Will increase. Then it means that the speed of the photoelectrons increases according to the formula, according to K max, which is equal to half m electron over V max, over V max squared. So the speed of the photoelectrons will increase because we have increased the kinetic energy by increasing the frequency. So this is how this thing is done. Yes. So you are having the frequency increasing. We are having the frequency increasing by using light of a higher frequency. And once the energy of the photon increase, or once we increase the frequency, then it means that energy of the photon will increase according to this formula. And when you increase energy of the photon, because we are using the same metal, then work function will remain constant. Then this then implies that the kinetic energy maximum of the photoelectrons will do what? Will increase. And then moving forward, the kinetic energy maximum is given by half ME, mass of an electron, and then V max squared. So when you increase the kinetic energy of the metal, of the photoelectrons, then it means the maximum speed of those photoelectrons will also do what? Will also increase. That is what I've done in here. So what are the implications on the current? Current is given by change in charge over what? Over change in time. So when you increase the speed of the photoelectrons, then it means the time will decrease, because increasing the speed, then it means the movement between 2 points of those electrons, the time that it will take for this electron to cover a certain distance will then decrease. And according to this formula, when time decreases, then we expect the current to do what? To increase, because according to this, they are inversely proportional. When current increases, then time decreases. So how do you decrease time? You decrease time by increasing the speed of the photoelectrons. But where does that come from? It comes from where I said you have used the light, you have now used the light of a higher frequency, which then gave us higher energy of the photoelectrons. For constant work function, kinetic energy maximum increases, and kinetic energy gives us the maximum speed of the electrons. Then this then implies that speed of the light will also increase because kinetic energy has increased. And once the speed has increased, then it means that our time will decrease. And When time decreases, according to this formula, we expect the current to do what? We expect the current to increase. That is how the intensity and the frequency of light affect the production of current in photoelectric effect. It is very, very important. So from here, what you can deduce is intensity. When you talk intensity, you will then end up with what? Whenever you increase intensity, you will then have more photoelectrons released per unit time or per second. So intensity does not affect the speed or the kinetic energy of the photoelectrons. Intensity only affects the number of the photoelectrons that are released per unit time. Whenever you change the intensity of light, remember that you will change the number of photoelectrons that are released per unit time. But when you change the frequency, when you increase or decrease the frequency, you need to know that you will then affect the kinetic energy like I've shown. When you increase the frequency or decrease the frequency, you will then affect the maximum kinetic energy of your photoelectrons, and changing the kinetic energy of the maximum kinetic energy of the photoelectrons will then affect the maximum speed of those photoelectrons. Meaning the speed and the kinetic energy will only change if we change the what? The frequency. The number of photoelectrons will only change when we change the what? The intensity of the light. But please remember that the frequency, the intensity of the light must be, that will have an effect, must be of a light that has a frequency that is greater than the what? The threshold frequency. These explanations are very, very important. So please be able to explain the effect of intensity. Our learners must be able to explain the effect of intensity and frequency on photoelectric effect. Okay. I think now we will take a short break, and then when we come back, we'll now do activities based on the explanations on the lesson we just had now. See you in a bit. Thank you very much.